So with that, let me hand it off to you, Nikki. Thank you for being here once again, and we're all looking forward to hearing your presentation.
Great. Thank you so much, Brendan. So I am really excited to talk to you today. Good morning, good afternoon, good evening, wherever you're joining us from. I'm happy to be here. I get to talk about two things that I really like today, sustainability and Quantrix, and how those things go together. That's what we're here to find out. So really, this is going to be a story around how we elevated some best practices from across our teams within our company across North America to a single standard that could be repurposed by everyone. And you'll also hear about how we're going to be moving from the science moving that into a standard process, and then moving the art into the hands of our teams. So we're trying to get out of the way of these creative engineers that I get to work with every day. So just a little bit on the agenda here. We're going to do an introduction by way of acronym soup. We love acronyms at Johnson Controls. Then I'm going to tell a little story about how everyone went from hitting the mark to everyone having an arrow. And so I really want to kind of think through, what that change looked like for us within the company. We're going to go through a little bit of a tool demo because, of course, this is about Quantrix and you got to see it, right? And then we're going to talk about what we can do next within Johnson Controls and where we're headed based on what we see in the business and then within our modeling capabilities as well. So first, as promised, the acronym soup and a little bit of an introduction about me. My name is Nikki James, and I'm a senior program manager for Johnson Controls. I've been working with the company now for 11 years. I started as a development engineer, working inside buildings and finding facility improvement measures for our customers to get them to improve their energy usage in a nutshell. So I started on my kind of first cutting of teeth within this world was on a very large project for the Colorado Department of Transportation. And that was, it was large in, not necessarily in like the dollars and cents perspective, but large in the sense that I got to travel to all four corners of the state, everywhere in between. And it really presented the logistical challenge for our team. And what we found was we needed something that could handle all of that data and do it effortlessly. And some of the standard spreadsheet tools just couldn't keep up. So a little bit about Johnson Controls, kind of give you a few clues as to what it is that we do, but we're a really big company that has taken a few haircuts recently and consolidated, divested from being kind of a batteries and automotive experience plus buildings business to really just a straight buildings business. So within that larger organization where we do HVAC replacements and build HVAC equipment and do a lot with controls within a building, we've got this business unit called Performance Infrastructure. And that's where I work. And that's where we've been doing these energy-based projects for years. So it's not just energy, it's anything that delivers an outcome for the customer where we're guaranteeing. And you'll see that this is evolving right alongside and honestly leading the way in the sustainability space where we're talking about guaranteeing outcomes when it comes to carbon and reducing carbon emissions for our customers. So we'll talk a little bit about that. I lead up a team called Performance Infrastructure Data and Technology, where I'm a lead program manager there. And our team is charged with building tools for this performance infrastructure organization. And so one of the tools that we got to build 10 years ago was Customer Solution Modeler, and that is built inside of Quantrix. As I referenced earlier, this energy service performance contracting model, it's really about taking the energy savings that we're going to get for our customers by making improvements on their buildings and guaranteeing those savings and using those savings to pay for the improvement measures that they just made. So just to kind of give a little bit of color and context around some of what we do. Shown up in the upper left there is a picture of the University of Hawaii at Maui. So in Hawaii, they've got a really interesting case where, of course, there's obviously some isolation there. They actually have to ship in diesel to generate their electricity. So when they're talking about these energy improvement projects, we're looking at energy costs that are at 50 cents per kilowatt hour, as compared to, in my home state of Minnesota, it's really around like 10 cents per kilowatt hour. So, so we've got a big lever there in terms of energy costs. Coupled that with Governor Ige, he was really leading the pack in terms of these aggressive goals to get to net zero. So it's kind of all over the news right now, and all across, from countries to local and state governments, these targets, these goals, these science-based goals to get to net zero, and usually the target is right around 2050. He was leading the pack in that. So we partnered with the state of Hawaii and the University of Hawaii community colleges to understand how we can make this happen for them. So with University of Hawaii at Maui, we're actually at 100% of their energy coming from on-site solar and battery. So this was a really powerful, impactful project for the islands. And you can see there, we were dealing with some real estate concerns, so we had to use these carports for some of the solar PV installations where we can't use ground mount or roof mount. So some really exciting technologies and some really exciting ways to deliver these outcomes for our customers. Up on the right, you can kind of see some of the strategy of how we might go about doing that and getting to that net zero outcome. So first, it's going to be, kind of your basics around lighting and controls, getting you a big reduction in your carbon emissions from your electricity usage, then going through some of the more capital intensive projects with HVAC. And then finally, kind of the last bit that you need to get to net zero would be through some renewables, either on-site or off-site. But in this case, with solar PV, as the case in the University of Hawaii at Maui. So just in total, kind of looking at what we've done as an organization, since January of 2000, which is when we started kind of measuring it, these performance contracting projects have helped out with over 30 million metric tons of CO2 equivalent emissions. And really what that means, because that's a big number, but we don't really necessarily, we're not able to grasp that abstract number. Think about it maybe as, taking 3 million cars off the road every year, or running 3,000 of those giant wind turbines that you see per year. So we're talking about a lot of energy and a lot of carbon reduction. So we're having a pretty tremendous impact. Historically, it's been really in these what we call the mush markets, the public sector, a lot of local government and K-12, and then others as well. And we're really trying to expand that out into the local, the light industrial and commercial markets more recently. So really the premise around this performance contracting, as I mentioned, and you can kind of see it in the bottom right so slightly, but we're really looking at how do we get a budget constraint organization, and this is where we've been really successful with K-12 schools and local government. How do you get an organization that doesn't really have the capital to make these improvements? And it's a lot of deferred maintenance within the buildings. It's a lot of things that they really wish they could do that they just don't have the money for. So building in these performance contracts, we're really just saying, we're gonna replace your lights, we're gonna replace your controls, your HVAC equipment, and kind of go down our list of improvement measures, and we're gonna save you money, and we're gonna guarantee that money, and it's gonna pay off your loan. So they finance the improvement project over 10, 15, 20 years. And in this kind of created example, it would be like a $7.5 million project. That's kind of in our sweet spot of project size. And then we finance that over the term and pay with savings over the term. So we've got to match, this is the key, we have to match the loan payment to the savings over time. So it's kind of the step payment strategy, because most legislation that governs this performance contracting model does not allow you to carry a negative balance in any given year. So it needs to be zero or positive. Of course, I'm sure there are many finance savvy folks on the call right now can understand that's deferring a lot of interest out into the future. So it's really a balance of how we try to make this work. How do we get these benefits up front instead of deferring them to the tail end where it's, you know, the interest is already accrued at that point, and really understanding how all these pieces come together. And the core of CSM, which is our customer solution modeler, what we built in Quantrix, is this modeling of the FIM item. Again, FIM, facility improvement measure. It's the core of what we do. And so here we're saying every FIM item has data surrounding it. It has install cost, it has savings, it has performance period cost, and so much more. It's got assumptions associated with the escalation rate of those savings, with operational savings, capital avoidance, all these parameters kind of surrounding the FIM item. And when we build these projects for the customers, we're really concerned with building up that project that meets their criteria: economic, deferred maintenance, strategic. All of those considerations have to be accounted for in a way that we can dynamically model these things in and out. So that's where Quantrix comes in. That's where we're able to turn off an entire FIM item. And because of that linked category, and because we're able to connect the FIM item all the way through the model, you turn the FIM item off, everything turns dark for that FIM item, and you see everything recalculate in the business case, in the cash flow, in the payback calculation. And that's a dynamic and live exercise that we do with our customers. You'll see on the screen in green, you know, a few other things that kind of go into that computation. But if we're really trying to synthesize the customer solution modeler tool that we've built in Quantrix, it's everything in that upper left. That's kind of the core of the structure of the model. So really, what does this mean for our users? For my customers are really internal. And it's my job to make sure that they can deliver to our external customers. So let's take a step back and think about how this works within this performance infrastructure development process. The star of the show is really the project development engineer, and I will admit that I am biased because I used to be one. That's fair. But really, they are the star of the show when it comes to CSM and building out these business cases for our customers. So they're the ones going in and auditing the facilities. They're identifying the facility improvement measures that we want to perform, that we think is going to be a good payback or going to be a strategic fit or a need for the customer. They're going to be calculating a preliminary business case that's really, I mean, it's really fairly lightweight. It's back of the envelope, not a lot of guts and detail in there, but then bringing in the detailed energy savings and carbon savings that they would do in a spreadsheet tool, a program like Energy Plus or eQuest, some government-sponsored calculation engines, some savings that we would take from our some specialty subcontractors and review and then incorporate. And then they're bringing all that into modeling that business case with the customer inside CSM. The account executive, they're in charge of really what that project looks like. So they're managing that customer relationship and understanding their needs. They're the ones in charge of figuring out financing and what we can get for the customer and what that looks like, if it's a capital lease or a contingent payment, or if it's just straight up cash. And they're trying to understand those needs from kind of that financial sense and really focusing on, you know, what are those financial parameters? What are the needs of the customer, and how do we package this up so that it looks right? Construction manager, they're on the cost side. What is it going to take to build these things out? And then the general manager, and this will become apparent later why this is important on the tail end of our process, but they're really going to be reviewing the project for risk and understanding, you know, what kind of margin potential we have for the project, what kind of risk is associated, because remember, we're signing up with these customers for 20, 30 years sometimes. So kind of flowing that out into a process flow, this is kind of how it looks. So as we talked about before, that development engineer is showing up in several places, but they're really at that core of that detailed business case. And it's important to understand too that this is iterative. So while we're going in and identifying scope and getting a sign off on the prelim, saying, yes, I want to go forward with you and develop this project, please, the calculations and the pricing, those can be dynamically coming in and out over time as we develop the project rather, and fine tuning it and getting more information. On the output side, that's where that governance and contracting is coming out. So the core is really around CSM and what we model in Quantrix. So, you know, I kind of mentioned at the beginning, this is really around a story, and it's a story around process improvement and standardization. And what I mean by that is we have to really rewind the clock about 12 years and look at where we were as a company then. Everyone was in spreadsheets. We had this spreadsheet tool called JCFacts, and it started out as, you know, it's got a standard name, but that's really where it ended. We had engineers across the country, probably at the time about 150 to 200 engineers, and in every branch, you know, Denver, Minneapolis, New York, you name it, everyone had their own version of the tool. And so they were recreating it and amending it, refining it every single project that they were building. As you can imagine from a management perspective, this became really difficult to assess risk on. And it became difficult for our customers too, because if we had multiple phases of a project, they might see a different version of JCFacts in phase 1 than they did in phase 2 when they decided to do more work with us. Hey, you know, why is this looking different? You know, and then from the engineering perspective, you had to go through the administrative effort of building this out every single time you're doing a project. So there's a lot of, you know, not high value work in going into building these models every single time. So this probably would have been fine if we were flat or declining, but we were growing. And at the time we were, I think, about $1 billion business. And we had a goal within 3 years to become a $2 billion business, fueled by, you know, a lot of excitement about renewables, ARRA money coming from the US federal government. So we understood that we needed to make a change fast. And that's where Quantrix came in, and that's where CSM came in. So we went from everyone hitting the mark because everyone was doing their job. Everyone was doing fine. We were selling projects, but we needed a tool. So everyone now has an arrow. And this is really about where CSM and where Quantrix kind of brought this process to life. So we consolidated best practices. We did a lot of requirements gathering. We did a lot of interviewing, and we made this model that was a standard and put it inside of Quantrix with a few kind of conditions. 1, everyone's got to use it. 2, there's no ability for our users, our end users, to modify formulas. And we even locked down a lot of the structure. We do it in a very surgical way, so to minimize the risk. There are certain categories within Quantrix that you can extend and contract and adjust. FIM items, obviously, you know, that's going to be different on every single project. But there are certain structural items, you know, loan payment, savings, that are not going to be different. We should be presenting a business case consistently across all of our projects, and we should be calculating it consistently. So a couple of things that, you know, this brought to life for us was really around increased efficiency. So we talked about needing to recreate models every time. Not anymore. Now someone just goes to a central repository, downloads a blank template, and they're off to the races. For a little bit of perspective on this, you know, our standard model right now has about 250 matrices, and 49 of them have that FIM items category within it, which is, remember, the core of our projects. So imagine adding a FIM to a project within a spreadsheet versus Quantrix. In a spreadsheet, you have to add it 49 times if you want the model to kind of propagate through. And you have to extend formulas, making sure that, I'm sure you set it up right, but you want to make sure that those formulas extend properly. With Quantrix, you don't have to worry about it. With linked categories, you just add an item, you remove an item, everything is seamless, and it's all connected. On the controlled calculations piece, a really interesting story that I'll never forget. When we were first training on CSM, we had the learners go through an exercise where they would take their spreadsheet model and they would put it into Quantrix. And by doing that, we wanted them to feel comfortable with the model, with the calculations, feel comfortable with the mechanics of putting stuff into Quantrix. And we were in Chicago, and a program manager, or a project manager rather, raised his hand and said, "No, I'm sorry, this model has a big bug in it. It's wrong." And so the trainer patiently, went over and said, "Okay, what's going on?" And he says, "Well, my cost is not adding up. This is a project that we are gonna, start building soon, and and if I had used this model, it would have been wrong." And again, patiently, let's take a look. So we went through and explained, with Quantrix, it's one formula. You calculate cost, it's one formula summing everything up. So, okay, so we couldn't really figure out where the problem would be in Quantrix. Let's go over to the spreadsheet model, and combing through hundreds of FIM items and cost entries, he realized that someone had gone into a spreadsheet that was a shared document and adjusted one single cell and overwrote the formula on one single cell. So, I mean, you could probably imagine he was not super happy about that unexpected change, and the financial implications for the project that he now had to figure out. The cost wasn't what he expected it to be. So I think I'll never forget it, because it's such a powerful story as to, how important these controlled calculations can be when it comes to these large complex models. The next point here around consistent format is it's really, that's been a huge win for us when it comes to closing projects. We've partnered historically a lot with ING on securing financing. And again, it was these spreadsheet tools that were all coming in different formats and different calculations. And it was a lot of work for our finance partners to try to understand and dig into the project to make sure that the calculations were right and matched their model. Now, we kind of vetted it with them. It's a single format and they're good with it. And our process of closing these projects has become much shorter. And the last point is really around known data structure. This is going to be important kind of later in the presentation when we're talking about what it is that we're looking to do in the future. But just the note here is really that structured data is more mineable data. If we know the structure and we can map it, then we can make use of it in other business processes. So now it's time for the demo. And let me just switch over to that and get you to the right screen. So what I'm showing up on the screen here is our standard customer solution modeler template. It's been filled out with some fictitious data just to kind of see how it works. But let's go through a little bit of a high level around this model. So we're still using a later version, or I should say an older version of Quantrix. We're at 6.4.5. So if this is looking a little dated, that's why. And that's an internal process for us. It's difficult for us to roll out newer versions, but we will get there. The other piece that I wanted to show you is around the model statistics. So when we're looking at this, call it a very average model and how we would expect, maybe the median of our projects to look. We're looking at a model with 200 matrices and about 1.5 million cells. And it's about an 80-60 split on calculated versus input. So I'll come back to this input piece in a minute, because we're not asking folks to put in, 600,000 points of data. This looks a lot scarier than it actually is because of some of the cool stuff that we've been able to template within the model. But the shockingly low number, for those familiar with spreadsheets, of 2,000, it's actually quite a lot, but it could be a lot worse. And so we've been able to really build off of this model in a lot of different ways. Oh, my apologies. There we go. So going through, if we remember the flow from, identifying the scope, the business case, and then the calculations and the pricing, we try to model through the workflow with using the perspectives menu. And so if we just kind of go through to project setup, for example, it's going to be, that high level building of structure. What are my sites? What are my FIM types? What are my FIM items? And then some global assumptions. Going through, you'll see the structure is kind of consistently, what's the bare minimum information that I need to add? Do I need to add some more detail? And then kind of carrying through topically around savings and cost, construction planning, performance period cost, and then getting towards the end where it gets fun and exciting around financing and managing those scenarios. One thing that I glossed over at the beginning that I want to be sure to mention is we found it really important in terms of the usability of the tool to make it feel like an environment that multiple people can come into. So this project model notes log is just, it's a very simple canvas and a way to track notes, but I see people using it all the time to try to understand where things are at when you've got multiple people coming in and making adjustments around some of these parameters. So it's just one way that we're trying to make it easier for these teams to work together. The other piece is around this problems panel, and I think it's something that we're doing in a very prescriptive way, is we're using this problems panel as a way to show completeness within the model. So as many of you know, the red errors indicate that I did something wrong in modeling. There's a formula error, which that shouldn't happen in a standard template. So we don't, that doesn't really pertain to us in a day-to-day, but the warnings, this shows you how complete the model is. So when you open up the blank template, you're going to see probably hundreds of different warnings. And we're using that via the constrained input to say, this cell is blank, it's an input cell, it's blank, it shouldn't be. So one way to complete the model is to kind of go through one by one and see where these cells are incomplete. And in this case, on the lighting retrofits FIM item, I'm missing a FIM type assignment. And that's a really key way that we group these FIMs by site and by type. And so if we don't have that assignment, there's a lot of functionality that gets broken kind of downstream. So once I fix that and hit refresh, I'm all good. So as I had mentioned before, there's kind of the scary 600,000 cell number for inputs. One way that we're trying to make things flexible but still easy for our engineers, for our teams, is to use a kind of a waterfall approach when it comes to inputs. So thinking about it kind of generically, we've got a high level input. We need the ability to override it at a detailed level, and it might be multiple tiers of detail to get to our output. And so what do I mean by that? Let's take the example of utility escalation. So utility escalation, most of you guys probably realize this looking at your energy bills, but utility rates tend to escalate over time. And so in this model, we're setting the default utility escalation across all of our sites, all of our utility types, everything as 2%. So if you were to just stop here and say, I set it at 2%, everything in the model would escalate at 2%. You don't need to go any further. However, there are nuances, there are details to be concerned about. So when I go into enter utility savings, I see down at the bottom here, I've got the ability to override that by site and by utility type. So I might say, well, you know what, natural gas is actually going to escalate a little bit faster at 3%. And, you know, Meadowbrook High School, it's a different electricity area or provider than the Brook Elementary School. So I know that they tend to escalate greater or in a more accelerated fashion. So I'm going to augment that to 4% escalation. Now, everything that I have in terms of savings at electricity consumption, Meadowbrook High School is going to be escalating at 4%. Same thing with natural gas, everything's at 3%, but I still haven't touched anything else. It's still at that 2%. And so you can kind of see how this would cascade down, and you could get several layers deep into your assumptions. We could even look at this over time and say, you know, actually my energy escalation rates within Meadowbrook High School, electricity consumption is going to be at 4% here, but then I don't think it's going to go 4% after year 5. I think it's going to, we should build some conservatism into the model and kind of temper that down a little bit. So you really get stacked on layers of being able to model at a detailed level, but only when you really need to. And that was a really big piece of what we built into the model. The last piece that I want to kind of mention here is around the customer reports and scenario manager. So, so kind of that core of the model is, as I mentioned, being able to model these scenarios. So the way that we've got it built out and structured is you're able to select whichever scenario you'd like, and you can make as many as you'd like, where you're basically just turning knobs on and off. So for this all except wind, you know, we take everything except the wind because we know that's going to be probably a poor payback and capital intensive. So that might fall out of the project. So we want to build a scenario around that. Or we want to build something that, you know, we can model on the fly and say, you know, maybe instead of all except wind, this is really a custom scenario. And this is something that we work directly with the customer to turn items on and off and dynamically see how the model adjusts over time. Okay, so I want to get to one more thing before leaving the model, and that's really going to feed into our future vision and why we need to get there. So there's so much good data in this model, and we really need to internally as a team work harder at getting the information out in a consistent way. So our first stab at it, and you know, for those who were on yesterday, you had probably watched Ben in awe, just looking at some of the scripting that he was able to do, is around this data table export. So I bring this up just to kind of show you, you know, I was talking to Brad earlier and we were talking about scripting. It really is something that a non-software developer like me can pick up to a certain degree. I don't speak scripting, but I was able to kind of build this out and at least get some information out in a consistent way. But as you can see, the script is painfully long, and it really goes around the fact that we've been updating this model annually, sometimes more, and it's been undergoing some significant structural changes. So we need to get key data out. That's our kind of our problem statement, and we need to get it out around the FIM, the site, and the project. So we build out these export matrices and build out the structure, we build out the formulas, but here's where it starts to get interesting. Then I have to try to understand what kind of model it is that I'm looking at. If I'm looking at a federal government model versus our base model, if I'm looking at a model that is of the, you know, of the vintage 2018 or 2017, right? Everything is changing over time and we need to adjust our scripting and our exports to accommodate that. So There's got to be a better way. And fortunately, I've got some super smart people on my team to help out and improve this process. So we're also customers of the Quantrix QCK, and we're starting to build this out and trying to figure out, how do we make this kind of hub of the process work better and tighter in terms of integrations. Where we've got some work to do kind of on the outside of CSM. So how do we get some standardization in terms of the structure of our calcs, the structure of our pricing? Those are separate efforts. But really, how do we then interchange that data in and out to accommodate that kind of iterative process? And then also importantly, how do we assess our risk on the tail end? So that's where Quantrix is going to come in from a QDK perspective and what we're trying to build out for the future. So we've already started, and we're really focused on making this a user selectable action, because we don't want to just assume that, at any given point when you close out the model, it's good data. We want them to declare, hey, this is good data, export the model. Or we want them to declare, hey, I'm at a point in time where I need to import some information that I know exists out there in your database. I want to import it in. Please give me that data now. So from a UI perspective, that's what we're looking at and exploring. But on the tail end, or on the export side, we really need to try to understand how to map all of these things together, and taking it out of the scripting, which I have to say, although it's a lot of lines and probably could be made more efficient, it's working right now. It's just not where we want to be in terms of centralizing and being able to make changes. Because what happens is, I think I've got all of the data that we need to get out of the model. I think I've, kind of got that figured out. And then someone asks for something else. So then I've got to go reach back into those old models again after rewriting the script or adding to the script and rerunning the script so that I get that new piece of information, core piece of information that comes out. What we're working on developing is something that does that outside of the tool, so that it can be adjusted, and that we can reach into these models and understand which version of template you are. And keeping in mind, we've got hundreds of each version of template. So there might be 100 version 2015, 100 2016. So the issue is compounding. And then, building that into something that we can more elegantly map this information together. So, a FIM item is going to be a FIM item is going to be a FIM item. That's easy to map all the way through. We haven't changed that. But there are new items, new calculations that we've done within the model recently that weren't there before. So do we have enough information in prior models to make those same calculations just given the raw data? Because we found that that's important. Or are there some assumptions that we can make to kind of make a proxy of that data? And it's really around making sure that we've got some good business intelligence and understanding the work that we've done and continuing that data on through the business process. Because although we focus this whole time talking about the development process, we still have to build everything and then maintain and manage the performance of everything for 20, 30 years. So this really sets the stage, and we have to get it right in terms of getting the data out of the model. And QDK is going to really allow us to do that. So that brings us to a conclusion here on the way that we're using Quantrix within Johnson Controls and bringing everything together within our business process. So I'm happy to answer any questions that you might have.
Great, thank you so much, Nikki. That was an awesome presentation. So yeah, there are a couple questions. The first one is, are you connecting multiple models for your solution or just one?
Yeah, great question. So we had definitely talked about doing multiple models and trying to bring them all together kind of initially. And I think the trouble that we have is really around CSM's predecessor was a spreadsheet tool, and there really wasn't any other way to do it. With the calculations and the cost, it's not as simple as that. The calculations can come from spreadsheets a lot, but they also come from Energy Plus and eQuest and our subcontractors. Same with pricing. Pricing can come from a scribble on a napkin pricing that was given to us by a subcontractor, or a PDF, or there's so many different ways that the data comes in that we really couldn't get our arms around it. So it's really just around that one model and bringing in information from various sources. I think you're on mute there, Brendan.
I am, thank you. Awesome. So the next one is, what sort of hardware does the system require, and how would you judge performance?
Great question. So historically our issues on performance were much earlier on. I would say when our standard issue laptops hadn't really quite caught up to where they're at today. And the limiting factor was really around RAM. And so now we've got our standard issue laptops are probably around 16 gigs of RAM. And so that's been sufficient. And then we bump up the memory usage in under the options panel to typically around, I think I'm at 8 gigs of RAM, which is, it hasn't caused any problems, and that's probably way more than I need. But that prevents that pagination issue where the calc wheel was kind of flashing and instead of spinning. And then from a calculation timing perspective, we look at model efficiency in reducing when we've got very, very large projects with the number of FIM items, kind of times the number of sites times the number of FIM types, because if you think they kind of all play into the size of the model. We work on building in efficiencies with our teams to say, is there a way that we can kind of cut down on that size? Because there can be, we can run into 30-second calc times with cycling through and modeling scenarios. And in front of a customer, we really need to minimize that as much as possible.
Awesome. Thank you so much. That covers it for the questions.